Hi, you're back with Mr. Canada, and we're going to look at adding in standard form today. So there are two methods for both addition and subtraction in standard form. Today we're just going to look at addition, and we're going to look at both methods though. So it's all preference. They're both completely fair methods, fair game. Uh, don't have to use one or you can use both, you can use one, you can use the other, as long as you get the right answer and you show your work. That's all that usually counts. Okay, so I'm going to start with method one because this is one that a lot of people enjoy and because it shows where stuff is coming from, but it often involves, in my mind, a little bit more work. So fully convert all the numbers to ordinary numbers, then we're going to add, then we're going to convert back. So what that means for us is I have to write this first part out. So 3, and then I'm going 1, 2, 3, 4. Okay? So this first number is 30,000. Now I'm going to look at this second one, because I know it's going to be plus after, and then 2 times 10 to the 2, so 2, and then 1, 2. So here, now I can add them together, and I can get 30,200. And that was actually quite easy to get that, right? Because they're nice numbers. They only have they don't even have a decimal. They're just one whole number, and they're relatively close together. So we're going to convert this back then and write it as 3.02 times by 10 to the 4. Okay? Sweet. But yeah, let's look at method 2. So method 2, it says that we change one of the terms so that the 10 to the n are the same for all the terms. Okay? So what's this going to look like? So I'm just going to rewrite the question over here. 3 times 10 to the 4 plus 2 times 10 to the 2. So basically the idea is we want to represent them all with the lowest power. So this is the lowest power, this 2. So we want to represent the other one as times 10 to the 2. So how are we going to do that? Well, we can say that this is 300 times 10 to the 2. Right? Because we just moved we moved it twice for here. Right? We just tacked on 2 zeros. So, and then plus 2 times 10 to the 2. At this point, all we need to do is add our values. Okay, not the standard form stuff, just the values. So those two added together are going to give us 302, and we're at times 10 to the 2 because we've used the same exact standard form times 10 to the 2. And at this point, you can convert back and just move the decimal place twice, so you get 3.02 times 10 to the 4. So it involves less writing out in the ordinary numbers and still keeping some of your compact form. So it's kind of preference. So let's look at example 2. So let's write these ones out. So we have 3.05, right? And we're going 1, 2, 3 to make it smaller. So I'm just going to convert mine first. And we have 2.5. And it's to the negative 5, so I'm going 1, 2, 3, 4, 5. So I know I'm going to have this nice tiny number. Okay, so let's add them together. It doesn't matter if it's a little bit messy while you're working through it, as long as you know what you're doing. So here, well, this is there, that's there, that's there. So I'm writing 0.00, and then a 3 is coming next, right? So normally we add from the right, but if you're kind of doing it side by side and you know what you're doing with your adding, then and you don't mind erasing when you have to carry something over, then you can do it this way, right? So my next number is going to be 7 and then 5. So now let's convert it back. So we're going to go 1, 2, 3. So 3.075 times 10, and we're negative because less than 1, this ordinary number, negative, and we said 3. Okay. Over here on the right, we're trying to do this. What does this look like? Well, let's put them all in terms of 10 to the minus 3, right? Would that be kind of the higher power, or lower power, I mean? That's what you have to think of, because I did say lower power before. So we're going to want to write it as both in terms of the times 10 to the negative 5. Okay, that'll be much easier to see. So instead of writing this 3.05, we're going to write 305 times 10 to the negative 5 plus 2.5 times 10 to the negative 5. So, as you can see, 305 plus 2.5 is just 307.5. And then times by 10 to the negative 5. But we have to move this at the end 2 spaces over. Sorry, 2 spaces over to the left. So that means we're going to take this negative 5 and make it a negative 3. So we get 3.075 times 10 to the negative 3. So, as you can see, it was actually much easier to do method 2 in this circumstance. So far, numbers greater than 1, it seems like ordinary method might be easier. This one, for numbers with negative indices, it might actually seem like this is easier. At least that's what I feel, at least. So, let's try this one and finish this off. So we have 3.5 times 10 to the negative 3. So we go 1, 2, 3. And then on the other one, so we're going to add this after, and we have 2, and then we're going 7, sorry. We're going 1, 2, 3. So we're going to have 0.0035 plus 2770. So this is going to result us in 2770.0035. And in a case like this, they probably would not ask you to put it back into standard form, because standard form is all about collapsing usually to 3 digits. So what they would do with a question like this, they would say it'd be a rounding question, and they'd say, okay, round it off to 3 digits and then put it back in standard form. So they would leave it as 2.77 times 10 to the 3, which would just be this. So they could use it as an accuracy, saying, well, does the other number just even matter when we talk about such large numbers combining with small numbers? And this is sometimes what we talk about in science is, as we can ignore error of instruments and stuff like that, because they're going to be negligible in the entire big scheme of things. So, saying that, if we do our other method just isn't going to show anything either, right? Because we're going to end up having to put it basically in a long string, and it's going to represent basically what we have on our left-hand side, because we're going to have to write out so many digits.